This 2022 Paper 2 Question 5, we have a sample of 400 students, 135 preferred remote learning. We need to figure out what proportion that is. Well, that's very easy. 135 out of the 400 people was how many that preferred remote learning. Then you can just get a number on that, and that'll be equal to 0.3375. Then we're told to use the margin of error 1 over root n to create a 95% confidence interval. So it's important that we just use this as our margin of error. That's it. And in order to make sure that you don't accidentally multiply by 1.96 or something, if you see where this comes from, that can be quite insightful. So anyways, our margin of error, well, it's going to be, this is our sample proportion. So obviously the actual proportion isn't exactly going to be equal to that. It's going to be in between what our sample was plus some or minus some error on the left-hand side, because it's going to be smaller. So our sample proportion minus some error, and then our sample proportion plus some error. So what's the error going to be? Well, the error is 1 over root n, so the error will be equal to 1 over the square root of 400, and that works out quite nicely because the square root of 400 is 20. So we have 1 over 20, and that's the same as 0.05. So if we do this, our 95% confidence interval, well, p hat was 0.3375, so 0.3375 minus 0.05 is less than or equal to p, less than or equal to 0.3375 plus 0.05. And then you can kind of just do the, I suppose, multiply those together. We'll add them together rather. You got 0.2875 is p, and then on this side we're going to have 0.3875. So yeah, there we go. Then we're told to make a more accurate 95% confidence interval, so we can use the actual formula. This is just kind of like an approximation, and you can see where that comes from, why it's an approximation. But this is our more accurate one. So for this one, our error is going to be 1.96 multiplied by this, because this is like how many standard deviations there are. So that's what we want. So our proportion 0.3375. So what we're going to have is we're going to have 0.3375 times 1 minus 0.3375. all divided by n, which was 400, and you can just get a number on that. And the reason you get a number on it is because in part 1 they said to do everything to 4 decimal places in the first 3 parts. So what you'll get is you'll get 0.04633, and then obviously we're going to need to round that. So we're going to round it to obviously 0.0463. Okay, and then for our confidence interval, we're going to have the actual proportions in between 2 values. So we'll have our sample value, which is 0.3375 on both sides, but on this side we're going to subtract our error, which is 0.0463, and on this side we're going to add it, which is plus 0.0463, and then you can add those together, and what you should get is 0.2912 p, and then we're going to have 0.3838. Then we have to do a hypothesis test. So we basically have a mean, and then they wanted to see if that mean has changed. So this is what they found for the sample. We have to see, is there a change? So we start off with a null hypothesis. So that's when we assume that nothing has happened. So that means that the mean has not changed. So that would mean that the mean is still equal to 20.279, euros. So 20.79 euros. And then our alternative hypothesis, which is what the sample is testing, is that the mean is no longer equal to 20.79 euros. Okay, so then how do we test this? Well, we have to do our confidence interval is probably the best way to do it. So this is how we get our error. So the way that it works is our sample mean is 22.16. So our sample mean is 22.16. What's the actual mean going to be? Well, it's not going to be exactly equal to the sample mean, but it's going to be in between 2 values. We just need to figure out what the error is. So the error will be the deviation of the sample mean, which can be 8.12. So you have 8.12 divided by how many people were in the sample. It's 500. So we have 500. We have to square root that. So the square root of 500. And then, of course, then what we do is that's like 1 standard deviation for the sample. And we want 1.96 standard deviations because that gives us 95%. And then you can figure out what that is. And that's going to be our error. So then our mu value will be 22.16 minus the error. And I'll have 22.16 plus the error. And mu is going to be somewhere in between those 2 bounds. So what we end up getting is about 0.714, I'll say, well, it's 378. I'm going to just round it to 4 there. 4 decimal places should be good. So then what we can do here is going to be 21.6 minus 0.7144. Then we have the actual mean will be there in between. And then 22.16 plus 0.7144. and then we can just figure out what these are. So what we'll end up getting is 21.4456, and then we have mu, and then we're going to have plus that value will give us 22.874. So that's where our actual mean is, somewhere in between these two values, just kind of supplied by the sample. So we want to see, is the actual mean 20.79? Well, you can see it's not in that, it's not within this interval, so it's very unlikely that it could be 20.79, because according to our sample, mu must be in between these two values, and 20.79 is not there. So our conclusion is that it has changed. So the conclusion, the mean is no longer equal to 20.79. Or in other words, we accept the alternative hypothesis. We accept the alternative hypothesis, and we do reject the null hypothesis. And then, of course, you have to give a reason, and your reason is just that 20.79 is not in your confidence interval. You could just write 20.79 is not in this confidence interval, and then you get your full marks.